Hey everyone, and welcome back to the Foundry by Forge College. I am absolutely stoked to be hanging out with you today. Now, if you joined us for the last explainer, you know we spent some seriously intense time in the debugging labs. We were deep in the trenches, chasing down those elusive failure modes and collecting enough messy post-incident data to give literally anyone nightmares. But today we get to take a breath. We're taking all that ad hoc, chaotic troubleshooting trauma, and let's be honest, it was a bit traumatic, and we're transforming it into structured, beautiful logic. We are talking about synthesis and operational playbooks. I want you to picture this. It is 3 a.m., your pager is absolutely screaming, a critical Solana RPC node is lagging out of consensus, and your brain is functioning at maybe, 10% capacity. Now, if you're relying on ad hoc panic, you are frantically scrolling through old Slack messages, just praying that past you left a crumb of context somewhere, all while the network keeps moving. Contrast that with playbook precision. You wake up, you open your meticulously engineered survival manual, and you just follow the clear steps. You don't have to be a genius at 3 a.m., you literally just have to be able to read. That is exactly the transition we are making today. So here is our master schematic for today. First up, surviving the debugging labs, then the playbook blueprint, next, setting metrics and thresholds, followed by writing foolproof runbooks, testing the machinery, and finally, getting ready for deployment. Let's dive right in. Section 1. Surviving the debugging labs, moving from ad hoc to repeatable. So, you've already done the heavy lifting in the labs, right? You isolated those nasty failure modes and collected endless triage notes. Now it's time to actually build the operational playbook. Think of this playbook as a formal package of monitoring checkpoints, remediation steps, and metric thresholds that makes your incident response repeatable. And listen, I really don't want you to think of this as boring administrative paperwork. It is so much more than that. Think of it as a psychological safety net. During a high-pressure outage, this playbook essentially automates your decision-making. You don't have to rely on sheer willpower and a pot of coffee to figure out what's broken. You just execute the plan. Section 2. The playbook blueprint. The core components of the machine. To actually tame the chaos, a structurally complete playbook relies on a few absolutely essential sections. First, you need incident classification, so you actually know if your hair should be on fire or if it's just a minor spark. You need monitoring checkpoints, so you know exactly which dashboards to stare at. You definitely must have escalation and communication, like who are you waking up and what exactly are you telling them? Then comes the procedural heart of the whole thing, the troubleshoot runbooks and remediation decision logic. And finally, you need a post-incident review template, or PIR, so you never ever make the same expensive mistake twice. Having all this ensures an on-call responder is guided seamlessly from the exact moment an anomaly is detected straight through to the final resolution. If you're missing these sections, you're not writing a playbook, you're just writing a wish list. Section 3. Setting metrics and thresholds. These are the sensors of your playbook. Let's look at how we transition from abstract signals into concrete action. We aren't just glancing at a dashboard and guessing if there's some general slowness. We track specifics. Take RPC 95th percentile latency. If it crosses 250 milliseconds, that's our warning. If it spikes over 500, it's critical, and we execute an immediate action. Open an incident and isolate the client. The exact same logic applies to resource alerts like validator CPU utilization. If it hits 90%, you don't sit around pondering the mysteries of the universe. You drain the node and add capacity. Zero ambiguity. The numbers dictate the response, completely removing all that stressful guesswork from the equation. Section 4. Writing foolproof runbooks. The gears that actually execute actions. Okay, so once those alarms ring, here's exactly how you build your step-by-step emergency map. Step 1, define clear trigger conditions. Step 2, list the required artifacts. Tell the responder exactly which logs or traces to pull. Step 3, write explicit commands. Guys, this is absolutely vital. You need to provide the exact copy-pastable CLI commands. You really do not want a sleepy, panicked engineer trying to remember syntax and accidentally wiping a production directory. And step 4, branching guidance. Basically, if the output is X, do this. If the output is Y, do that. Keep it explicit, keep it numbered, and completely devoid of vague prose. Your runbook should read like a machine execution plan. And here is a golden rule for Web3 DevOps. Every single remediation step must be tied to a specific, measurable metric goal. You cannot just run a script, shrug your shoulders, and declare victory just because the Slack channel went quiet.
State your goal up front, something like reduce 95th percentile RPC latency from X down to Y. It's really the only way to definitively prove your fix actually worked and wasn't just a lucky coincidence. If you don't tie your fix to a metric, you aren't engineering, you're just hoping.
Section 5. Testing the machinery. Validating your invention. Look, an invention is completely useless if it shatters during its very first stress test. So to pass our deployment milestone, we use rigorous acceptance criteria. We do a structural completeness audit to ensure no sections are missing. We push test traffic to verify those thresholds and see if the alarms actually trigger when they're supposed to. We do a full dry run of the runbook in a staging environment, gathering metric-driven proof that our fix works. Prioritizing this kind of testable validation is a core element of the engineering programs you'll experience at Forge College. We don't just want theory here. We want battle-tested, resilient systems that can handle real-world Solana deployments. Now, the ultimate boss fight of playbook validation is the pure clarity test. It asks one very simple question. Can a coworker execute your runbook in under 2 minutes without you standing over their shoulder explaining it? If they are frantically fumbling around for a dashboard link, or if they hit a wall because they lack permissions that you forgot to write down, your blueprint is flawed. If your teammate can't understand the runbook in a complete vacuum, you need to go back and rewrite it until it's perfectly clear. Section 6. Ready for deployment. Integrating the operational core. Before we wrap this up and fully integrate our operational core, we have some final but critical housekeeping. You must verify your access control hints, meaning document exactly who has the authority to run these scripts or trigger a rollback. Furthermore, ensure you are using stable identifiers and static URLs for all your dashboards. Seriously, nothing causes more sheer panic during an outage than clicking a monitoring link and getting a 404 error just because someone renamed a workspace. Good documentation hygiene makes integrating this playbook into your broader deployment plan totally seamless. If you take away anything at all from this explainer, let it be these 3 guiding principles. 1. Structure matters, so you can find procedures quickly even while you are half asleep. 2. Metrics drive decisions, which ties your actions to measurable, objective user impact rather than just gut feelings. And 3. Documentation must be actionable, meaning minimal prose and explicit executable commands. Stick to these 3 things, and I promise you, you will survive even the toughest on-call rotations. So, I want to leave you with this final thought. Is your operational blueprint truly ready to be integrated into a comprehensive deployment plan? Have you actually passed that 2-minute peer clarity test? Remember, this playbook isn't an endpoint. It is the operational foundation for everything you deploy next. Thank you so much for joining me today. Be sure to visit forge.college to learn more about this subject, dive into more advanced Web3 topics, and take your engineering skills to the absolute next level. I'll catch you in the next explainer.